Hey guys, this is Kurt, one of the members of the roof framing and geometry group. I am a specialty heavy timber designer and fabricator. I use three-dimensional modeling to do virtually all of my roof framing these days, and I don't wear bags in the field anymore. The computer is my tool, but the Power of CAD I think would be interesting to some of you folks. So I wanted to do a quick video about Raphael's interesting problem here, which is unequal pitch hip roof with a consistent overhang or fascia, and it's an interesting problem that I'd like to show you how I do in CAD. This isn't going to be a CAD tutorial, so I'm just going to kind of blow through it kind of quickly, and here we go. So the information we've been given is that this is a roof that has two pitches, 16 and 12, and 8 and 12, and it has a roof overhang of 32'6", a full roof size of 32'6" by some unknown distance we'll just call 45 feet. And I'm going to start by drawing in plan view, so looking down bird's eye view, a rectangle that is 32'6" by 45 feet. So this is going to be that rectangle that Raphael drew, and I've got that post right here. So this is going to be the outside overhang of that. And now I'm just going to offset that 16 inches for our face of stud or grid line of the wall. And now in CAD, it can be helpful to change these things around a little bit so that you can keep track of what you're looking at. I've made that dashed now. So this is our roof, and we're certainly going to have a ridge running down through the center of it. It's going to get truncated off where these hips come up in, but we're going to figure out where that is and draw that accurately. So the first thing I do is draw another rectangle on another layer here. And this is represents um, the ground plane. So you'll see what I mean here relatively quickly, in that I'm going to start drawing a section cut, and we'll just imagine the cut being right through the middle here where there's no hips or anything like that. I'm going to draw that section cut where the floor is this line right here. So I'll start doing that, and I'll do it by dropping some construction lines. I'm going to change to a different layer so we can keep things straight. And I'm going to drop some construction lines down at really just the wall line and the overhang fascia line. So this is an 8 and 12 roof, so I'm going to go grab my 8 and 12 template that I've already made because I do a lot of this. And since this is the wrong side, I'm going to quickly mirror it so that we've got the orientation correct for that. And since I don't need the original one, I'll take that off. Now I am going to we'll just assume that we're going to use 8 foot 0 3/4 plate height for this. So I'll offset this floor height 8 foot 0.75 right here, and I'll offset that up, and that'll give me a top of my top plate. So I can just move this whole entire assembly from the corner right here to right there. Now I've placed my wall on the grid line, and I will quickly just stretch the bottom of this wall down there. So now I've drawn what would be a typical 92 1/4 stud, 8 foot 0 3/4 overall height. My fascia overhang, we typically use 2x12 rafters out in the west and in the mountains to get the strength we need and the overhang or the insulation cavity that we need to meet the energy requirements. So you can see that that's for ALS dry sizing at timbers, that's going to be 11 1/4 inches deep. So I will just move my fascia line back to this intersection right here, where and now we don't need the dimension, and we no longer need that. And I will just simply trim some things off to clean it up here. And I'll erase the vertical lines that we put in because now I've placed that wall at the correct location. I want the same condition on the far side over here, or on the other side. And I know that that mirrors around the ridge, so I can just simply mirror around the ridge and then use some quick AutoCAD tools for filleting two lines together. And now we've got a gable peak condition, and these should all be on layer 2. So now we've got that the peak condition. Raphael also told us that we have a 2x12 like compression ridge. It's not we don't do a whole lot of these back in the West, but I put a 2x12 in there. I will center that right at the peak, and then I will drop it down so that we don't have to bevel or back cut the ridge for any sort of decking. So that's going to be the location of our ridge, and now these rafters will get cut off like this, probably, assuming that's the way you guys do that. And now that's going to be our kind of condition that we're going to have for the ridge. So I've constructed the first section, and that's kind of the theoretical section. I've gotten a perfect fascia point out here, a theoretical roof plane. That's going to be the top of my rafter here and the top of my rafter here. So now I'm going to rotate around to this other side, and I'm going to draw the exact same section running through the other side of the building. And I'm going to draw that at 16 and 12. I'll use a little quick tool I've made to do that, rotate myself around so that I don't have to draw sideways, which is not the way my brain works. And we'll just do the exact same thing. I'll choose a different layer to keep it straight, but we will do the exact same thing there. This section is now going to be slicing through somewhere along here, like maybe like this. So we'll do this exact same thing, and I will grab because it doesn't matter which one, I'm just going to grab any one here. Bring it down here, rotate it so that it aligns with what we need, mirror it again around. And it's kind of silly that I did all that because all we really needed from this was the wall, because this roof rafter is incorrect. So I will draw that. I'll change the layer here quickly. I think we're using 3. So I'll draw a quick 12 and 16 to establish, and then I'll connect the dots to establish my 16 pitch right there. I move that just quickly to get the construction going. I move it out to the edge right there. And I will move this somewhere else. Maybe we'll just use this for a little housekeeping here. Just so that we know what we're doing. There's our little tag for the roof pitch. Now, I typically like to do these things. I don't use the height above plate method, so I'm just going to offset this 11 1/4 to get 2 parallel lines that represent the rafters. And I'm going to just move this to getting middle bearing, and this is the methodology I use for this stuff. Feel free to do what you want, but this works well for me. Now I'm going to move this entire thing over to our grid line like we did before. So now again, I've got faces stud right on our grid line. I'll extend the top of the rafter, and I'll just draw a square cut perpendicular back to there and fillet those two together. So now that represents the rafter, and I can erase the construction lines I used to line it up here. I will stretch again the plate down to the bottom, and this is one of the reasons I use this method, is that now to get the height of wall consistent all the way around, assuming that we're going to the first attempt we're going to do it, this is going to try to use a consistent wall height for the entire thing at 8 foot 0 3/4. So we will offset again, and this time we'll use this 0 line, or the floor line. And what that does is allow me to transfer heights from one view to another view over here. So now, and I did it incorrectly because we don't really want to use the wall height. What's important to us on this particular project is making these top fascia corners meet. So what I want to do is offset the distance from the tip of the fascia to the 0 or floor line up. And so now I've got that line running through the corner of my fascia, and I can stretch my entire wall to the right height for that. Now I can take a quick look at how that works for 8 foot 0 3/4. I assumed a middle bearing sort of seat cut here because this is the way I like to start things. But if I want to see if I can try and make that 8 foot wall work, I can do the exact same thing here. I'll offset this floor line to the top of the wall, compare that around to the other side, and see what I get. And it is not going to work very nicely for me, because if I want to use that wall height, I would have to have my wall down here for consistent fascias. So we're not going to probably be able to use a consistent wall height on this, so I'll just get rid of it and we'll use my half bearing solution for the 16 and 12 rafter. But I do know that I have the fascias lined up again, because real quickly again to show you, it's even height, the corner of the fascia here, which I think is one of the most important things that's driving this design. So now we'll use the same method we used a few minutes ago to mirror this over and connect the dots. So, yeah, so why don't we just do that first right off the bat here. We will mirror this from the center line of this building over here. And next thing we want to do is, we know these hips only come up to the ridge height here. So what I'm going to do is, I didn't need to trim those. I'm going to use that same offsetting method and offset the floor to the ridge. So now I've got the height of the ridge perfectly right here. And I will extend both of these up there and both of these up there. What this does is now give me this kind of intersection of the tops here. So now I can actually, in my floor plan here, I can take that top intersection there and there, change my layer now to this one, and I can draw my hips in. So I'll just draw a line of my hip to there and back down to the corner, and the same thing on the other side. So this is our roof now, and we have trimmed that. So there we go. Now we've established our geometry in both directions, and we have our roof. But the whole thing is all 2D. This is basically just drawn flat on the ground, if you imagine snapping it all out on the subfloor. I'm a big 3D guy because I use a lot of CNC fabrication stuff. And I tend to work out the geometry in 2D because that's fast and easy, and then transfer that into 3D. So what I will do real quickly here to show you how that goes, if we turn this around and start spinning and look in a 3D view, I'm going to grab it and twist my whole model here. We can see that this is kind of just all drawn flat on the ground or on the subfloor or something like that. So what we want to do is start working this in 3D. Well, we've figured out all the geometry perfectly in 2D. It's just laying down flat. What we'd like to do is have that geometry flipped up into the 3D world, and then we can trace everything into the 3D world. So I'll go back to my plan view, and I'll do a couple little things that I won't bother explaining here that will help me rotate this around into a proper orientation. So I'm just going to rotate that up into the 3D world. So now we can see that my section is drawn up in 3D like the building would be. And I'm going to do the same thing with the other one. So now I've rotated both of those sections around up into 3D view, and I have the floor plan or the roof plan and the wall outline. They're drawn still down on the ground. So I'll grab a new layer. Now we'll go up to this layer 4. We'll use that one. And what I want to do now is start creating this roof planes that we've defined here in 2D. We figured out in 2D, and they're projected down onto the ground. I want to create those up in 3D so that I can just throw some hips in and have points to snap, pick down at the bottom here and at the top here. so that I can throw that hip in 3D space. So the way I'll do that is to create another roof plan, but this time it'll be a wireframe in 3D. And so I'll do that by, oh, there we go. I will do that by working in 3D space, and I will draw some lines that represent the fascia points. And this is now this is a line up in the in elevation world, up in 3D. I'll snap one to the ridge and one to the lower fascia there. And I'll do the same thing for the fascia and roof intersections for the 16 and 12 pitch roof. Now I've done that, I'm going to go ahead and turn this layer 1 off with the plans down there so that it doesn't confuse us and we don't have things overlapping. But now I can trim stuff up and clean it up. So these are the points that I was really looking for. We'll spin it around up into the 3D world again, and we see that our fascia is lining up. This is a box representing the fascia. We can see that it's lining up real nice with our fascia there, and the ridge is there. So now all I need to do is connect the dots, and I have created the theoretical roof plane geometry in 3D at the correct height with the correct pitches. So this is really it in a nutshell. If you wanted 2D, you can just take these rafters and draw some diagrams, and now you've got your seat cut and your overhang and dimension them, and you get your length. But again, I'm a 3D guy, and so I'm going to send it to the CNC machine instead. In order to do that, I need to define the hips and valleys, and I've got a software called HSB that's on top of my AutoCAD. It works. It's designed for like timber frame industry and for exporting to CNC machine. It has a bunch of roof tools for rafters and hips and valleys and jacks and all sorts of stuff. But we need planes defined, and this isn't really quite enough to define a plane in this software. So we'll use a couple quick tools here to draw some planes, and I will just quickly, this is a very simple tool. All I have to do is snap around the different planes, and it will create some surface definitions that the software will use to be able to put hips and valleys and jack rafters and that sort of thing in here. So I'll just quickly create 4 roof definitions, and I will turn, I'll make layer 5 now current, and I will turn off the other layer we were working with. So now I have these roofs definitions, and I can use my software to insert hip and valley. So I will say timber, add a hip or valley. It tells me to select 2 roof planes for a hip or valley. I'll put it in there, select those 2. It gives me options to be offsetting them or dropping them, but for now, we'll just stick with. I know that a hip or valley is going to need to be deeper than the rafter depth, so we'll just call it 14, see if that works. And we'll just go ahead and use 5. Maybe we'll assume this is LVL type material or something like that for the hip. And now it has automatically inserted that hip, and I'll change the visibility because, and while I'll do the same thing for the other pitches. And I'll change the visibility of this because this is kind of wireframe where we're kind of looking through everything. So we can see what's going on. I'll change the visibility to a shaded representation. You can see that we've mitered the corners of the hips and valleys, the hips. The hips have been centered on the roof pitch line. I could have offset them if I needed to. I could have raised it or dropped it, but it's given us the automatic back cutting of that hip in order to meet the roof plane. So now we've got that hip definition, and we can go back. The only thing we need now is maybe a ridge and some rafters. So let's go ahead and do that. I'll change back to the other 2D view because it works quite a bit faster, and we'll look at it in a different view. I drew the ridge in here in this view, so I can just go ahead and put a timber in and trace that, where I will say, let's just use a beam, 11 1/4 by 1 1/2. I've already got 2 by 12 set up here, and we will just put it where we snap it to. So quickly, that's the rafter at the right height, but it's in the wrong location because it's all the way out here. So I'll use a little tool that helps me move stuff around quickly and easily, and it's move this only in the Y direction, and just from there we'll bring it up to maybe face right on those, and then I can grab it and grip stretch it down to somewhere like here. And obviously, if we're going to detail this out a little bit more, I'm going to run it a little bit more. I'm going to back cut it for these two hips, but we can see now in our shaded view that we have the two hips and the two valleys in there, and we can just simply add some rafters in there. So add a rafter, pick a roof to add it to. We'll use that one. What height of the rafter do we want? This is set up right now for timber, so we'll go 11.25, and we'll just do 1.5. For a simple 2 by 12 rafter, and it asks me where I want it. I'll just snap it to the middle of everything. We'll do the same thing on this side over here. This is our kind of common rafter for the 8 and 12 pitch. I'll do the same thing over here. We'll maybe center our layout if we want that, and on the other side, just for fun, we'll do the same thing, but then I can move that rafter. We'll just go 8 inches, and we'll maybe, and you can see that it's automatically readjusted itself to be cut flush to the face of the hip. So there you have it. There's unequal pitch roofs with a fixed fascia height in a hip roof condition. I could develop this more and put some objects in here to represent the wall lines and cut the seat cuts out of these rafters, trim them up so that they don't go through the ridge like this. Instead, cut them so they face onto the ridge. And then we can send this all to the CNC machine. Or we could conversely, if you don't have a CNC machine, we can take these and then just dimension them and hand them out as shop drawings for what to cut in the field. Anyways, hope you enjoyed it. Where we at? 22 minutes. I probably could have done it in half the time if I didn't narrate the whole thing. Maybe half the time, 2/3, 3/4 of the time, something like that. So 15 minutes, not bad. All for now. Have a good day.